do your talk.
Yeah, I'll turn my video off. I think it'll help on the bandwidth.
Okay, so I'll put your picture up then.
Yeah, that's a better picture anyway.
Okay. Okay, so Chris, are you just gonna turn your video off when you start to do your talk? Yeah.
Yeah, I'll turn my video off. I think it'll help on the bandwidth.
Okay, so I'll put your picture up then.
Yeah, that's a better picture anyway.
Okay. Oh, something's going on here. We're getting a time delay, Chris. Okay, so Chris, are you just gonna turn your video off when you start to do your talk?
Yeah, just give me a minute here.
Yeah, I'll turn my video off. I think it'll help on the bandwidth.
Okay, so I'll put your picture up then.
Yeah, that's a better picture anyway.
Okay.
Are we stuck in a Star Trek
something's going on here. We're getting a time delay. Okay, so Chris, are you just gonna turn your video off when you start to do your talk?
Yeah, just give me a minute here.
Yeah, I'll turn my video off. I think it'll help on the bandwidth.
Okay, so I'll put your picture up then.
Yeah, that's a better picture anyway.
Are we stuck in a Star Trek
something's going on here. We're getting a time delay. Okay, so Chris, are you just gonna turn your video off when you start to do your talk?
Yeah, just give me a minute here.
Yeah, I'll turn my video off. I think it'll help on the bandwidth.
Okay, so I'll put your picture up then.
Yeah, that's a better picture anyway.
Are we stuck in a Star Trek
something's going on here. We're getting a time delay. Okay, so Chris, are you just gonna turn your video off when you start to do your talk?
Yeah, just give me a minute here.
Yeah, I'll turn my video off. I think it'll help on the bandwidth.
Okay, so I'll put your picture up then.
Yeah, that's a better picture anyway.
Are we stuck in a Star Trek
something's going on here. We're getting a time delay. Okay, so Chris, are you just gonna turn your video off when you start to do your talk?
Yeah, just give me a minute here.
Yeah, I'll turn my video off. I think it'll help on the bandwidth.
Okay, so I'll put your picture up then.
Yeah, that's a better picture anyway.
Wow.
Well, that's a blessing.
It's
It sounds like the whole story.
Did somebody cross the streams or something?
Okay, Dave, sorry about all that. You had to bear with me. Are you now seeing the opening slide, August 7th?
I've seen the correct slide now, yes.
Good. We are live. We are recording. We have 5 minutes to go. I can now breathe easier.
Okay.
That was just quantum fuzziness, you know.
No, what you were hearing is that when I broadcast live on YouTube, I suddenly start watching YouTube with the volume turned on with a 5-second delay, so, until I had the time to turn it off, as I was over in Facebook posting that we are live.
Well, I thought it was 2001 going through a time warp.
Okay, what I haven't paid attention yet, I now can, is how are we doing on panelists?
I think we're not too bad. Hugo, I don't see any video. You've been
Yeah, I'm having the same problem I had last time, and I clicked on the start video thing, and it didn't seem to.
So wiggle your mouse lower left-hand corner there.
Yeah.
You'll see the microphone and see. Do you have a line through your video?
Yeah, start video. There's a line through it.
So just click on that.
Yeah, I clicked on it. And nothing happens. It says, I get a message, cannot start video, failed to start video camera. Please select another video camera in settings. Oh,
Okay,
well,
so try unplugging. Is your video camera external?
yeah.
Unplug it, plug it back in, and then try again.
And as a reminder,
here we go.
Dave,
You're there.
Hey,
Hugo.
how about that?
Yeah. Okay.
as a reminder, Dave, I almost forgot this. We are in practice mode right now, which is a good thing.
Yes.
We are live, but we're not visible to the online audience.
Oh, okay.
But I'm ready to go anytime you want. So we're 7:28.
Yeah. Well, we'll start right at 7:30. So.
And turn off the.
Now, in terms of panelists.
Can you hear me fine?
Yep. No problem. Maybe a little louder.
And you've got my audio?
Yes, Rick.
Yeah.
Thank you. Okay.
Okay.
So I
How's
think
my audio?
it's good. Jim,
Okay.
how's your audio?
Testing 1, 2, 3.
You're good. Okay. I think we've heard from everybody. Well, Brian?
I'm here. I'm here.
Yep, good. Okay. And Raymond, I'm pretty sure you were in earlier.
I'm here,
Okay,
just
good.
sitting back.
Okay, not a problem. Just don't fall asleep now.
And a question to Jim Thompson. I haven't seen any further emails today. Are you attempting to continue on after the meeting live astronomy?
Yeah, that's the plan. So I have the cameras and scope are all opened up. I just need some time when it's dark to focus and align, and then I'll be ready to go.
Okay, so maybe you can make him a co-host now then, Chris.
Good idea.
Jim, are you okay there? Jim?
Yep.
Okay, just making sure we can hear you. Okay.
I may not be able to get him as co-host. I have a mouse on one screen, not on the other.
Okay, well, what we can do at the end of the meeting is we can stop sharing the screen.
Yes.
And then at that point, you can make him a co-host.
Exactly.
Yeah.
Can you make him a co-host?
Oh, probably. Yeah. No, I can't.
Okay, no pressure, but here we go live.
Okay.
Oh, come on. Where's that stupid mouse? Go.
Okay. Okay, folks, so welcome to our August 7th meeting of the Ottawa Centre of the Royal Astronomical Society. We're just going to pause for about 2 or 3 minutes as people quickly join the group. I see the numbers climbing here. Maybe let's just stay on the screen for a minute. Wait till everybody comes in. We're up to 58 participants. So just wait until a few more people come in here.
And Dave, this is Chris, just so you're aware, when I checked just before 7:30, we have 98 people registered, and I believe that does not include the 13 panelists.
Okay, that's good, good count. As soon as the number stops scrolling up, I will proceed, but we're at 62 so far. A special welcome to those joining us from other RASC centers or visitors here this evening as well. For those of you who don't know me, my name is Dave Chisholm. I'm the meeting chair for the Ottawa Centre. Okay, I'm just going to mute you there, Oscar. There we go. Okay, so folks, welcome to our meeting. And Chris, if we can go to the next slide, please. Okay, as this is a Zoom meeting, just a couple little security things. We will not be monitoring the chat box. You're welcome to chat among each other during the meeting. If you need to ask a question, please use the Q&A box. What I will do is I will look at all the questions, and if they're appropriate, I will ask them at an appropriate time to the panelists that are doing the presentation. For your security, do not click on any web links that might appear in chat or Q&A windows. Sometimes people hack into our meetings and put links to things that you really don't want to click on. Okay, next screen, please. Okay, so here is tonight's program. The 10-minute astronomy news is actually 3 minutes and 45 seconds of astronomy news. It's a video that I've got, so that we'll be gaining a little bit of time there. We've got the Ottawa skies for July. We have Paul Klauninger doing imaging Comet Neowise. We have Robert Dick doing the magnetic telescope clutch, and Hugo Lama imaging the moon with a cell phone. We have 1 or 2 images of the comet. No, we actually have quite a few images of the comet, plus some other amazing images for the observations. And we also have the monthly observation challenge following that. So let's move on to the next slide. So we have a number of new members that have joined us. So welcome to the Ottawa Centre. And we've got 38 new members in 2020. So we're doing really well here. So welcome. We have a number of members in the news. So we have the, is somebody going to speak to this or am I going to speak to it?
You are, Dave.
Okay, thank you. So unfortunately, we have to announce that one of our very early members of this organization passed away, Lloyd Higgs. He was quite active in the 60s and the 70s, and you can see his various positions even in the 80s for that fact. Yeah, a number of the folks know him, and there's his obituary information there. So yeah, he was quite active in the local center back way before my time.
Dave, if I can just add something there. In the time that he was a member, there was a strong component of the Ottawa Centre made up of professional astronomers with the Dominion Observatory. And in fact, I believe he was the head of the Dominion Observatory in Ottawa until it was moved to British Columbia. And that's when he left the Ottawa Centre but continued on obviously at the national level. He had a long career as a professional astronomer with the Dominion Observatory.
Okay. So congratulations to Robert Millard, who has completed the requirements for Explore the Universe certificate. And this is something that we encourage all members to work towards, particularly new members. And all that information is on the national website for the RASC and what you need to do for that. So he had received that electronically on the 30th of July this year. And then on the next slide, there's a new certificate called Explore the Moon certificate, and Robert Millard has also completed the requirements for that. So congratulations, Robert, on that accomplishment. And our resident media person, Gary Boyle, had one of his images of Comet Neowise published in the Ottawa Citizen on July the 15th. And I heard him the other day on CTV. He did a very good job talking about the upcoming Perseid meteor shower. So congratulations, Gary. Okay, so as you're all probably aware, they just recently launched the spacecraft to Mars with the new Perseverance rover. And embedded on the underside of that rover is a little helicopter that they're going to be flying around there. And so this is a short video about that. I'm hoping in the fall here to get 2 Canadian scientists that are involved in this project to come to speak to us. I still have to confirm dates and times, but one of them is somebody who is a specialist on the working on the mineral extraction, and one of the others is an actual driver of the Perseverance vehicle. So I've contacted both of them. I've contacted one of them, and I'm hoping to get them scheduled sometime in the fall. So let's go on to the video on the next screen, please.
And Dave, my apologies, I have to interrupt. Even though we discussed this minutes before the meeting, I don't believe I've turned on the audio for this next slide, so bear with me. Sorry to the audience, I have to interrupt here.
Okay. Yeah, with Zoom, if any of you've worked with Zoom, if you want to show something with audio in it, you have to tell the system that you want to share your computer audio before you start the slideshow. So let's try this and see if it works.
Sometimes you have to do something just to show that you can do it. When the Wright brothers flew for the first time, they flew an experimental aircraft. And in the same way, the Mars helicopter is designed to show that we can fly powered helicopter flight in the Martian atmosphere.
From day one, this was the unwavering dream of our team, to get our helicopter launched to Mars so that we can get that opportunity to do that very first rotorcraft flight test in the actual environment of Mars. It's extremely difficult to fly at Mars because the atmosphere is so thin compared to Earth's at Mars is less than 1%. So the first and foremost challenge is to make a vehicle that's light enough to be lifted. And then the second is to generate lift. The rotor system has just been very fast. 2,000, 2,200, 2,400, 2,600. We're spinning between 2,000 and 3,000 revolutions per minute, and it takes a lot of energy. So it's that balance of a very light system, yet having enough energy that's needed to, spin the rotor so fast to lift, and on top of it, having to design in the autonomy.
It has to be fully autonomous from the time it takes off to the time it lands. What we do on the ground is we plan the flights, and so we determine from here where we want the helicopter to go.
Our experiment window is 30 Martian days. So we have planned up to 5 flights of incremental difficulty.
Very first flight, the main thing is we want to get the legs off the ground, and so we will basically go up about 3 meters, and we'll hover there, and then we'll come down again, and that will be the first, really major milestone.
Most of our flights will be at the 3 to 5 meter height. We will be going horizontally again at a few meters per second, probably go out, 50, 70 meters and come back. In successive flights, we'll probably push that further, try to go further. So our priority will be to get back engineering telemetry and not so much images, but I'm sure we'll return a few, because they'll always look cool.
At this point, we've tested all we can on Earth. We have mathematical models that shows how it'll fly at Mars, and we've tested it in the simulated environment that we can create on Earth. It really is time now to do the real flight tests at Mars.
Nothing is a given, but we have done everything we can in terms of a test program here on Earth. The vehicle's performing extremely well so far. It's been doing exactly the right thing, even right now, and it's bolted onto the Perseverance rover. So there's a very good chance that we'll pull it off, yes. But it's still high risk, and none of us forget that you could have a glitch that, could mean end of mission, yes.
It's going to be exciting, reacting to any surprises we have. We can't wait. What's really most important is everything we're learning here is for the future rotorcraft systems that we want to introduce into space exploration.
Okay, so hopefully folks enjoyed that video. It's good to sort of see what's coming up with the latest Mars mission. So let's take a look at the Ottawa skies then for August. And Chris, we can go to the next slide. So this month I actually got the correct month up. Sorry about last month. So the full moon was on August the 3rd, and that full moon was known by early Native American tribes as the sturgeon moon because of the large sturgeon fish in the Great Lakes. And it is also known as the green corn moon and the grain moon. The new moon is on August the 19th. Next slide. Comet Neowise. So where that big yellow arrow is approximately where we are today. And you can see that it's getting lower and lower in the sky. And that gives you a rough spot of where it is. I know that I'm pretty sure I've looked at the slides that Paul Klauninger is doing, and he'll give us a little bit more detail exactly where it is in the skies. Anyways, it's still something that we can observe. It is getting a little bit dimmer at this time. Next slide. Okay, the big event this month is the Perseid meteor showers. The Perseid meteor showers peak on the night of August 11th and 12th. That doesn't mean they just suddenly turn on then. They're actually up there over a period of time from July 17th to August 24th. Now, on that night, typically we say go out after midnight, and even though there is a moon out, there's a quarter moon out, there is a window of opportunity, I would say, between 11 and midnight before the moon starts to rise, and the moon rises at 5 minutes after midnight. So I would say the best time to possibly see them without any interference from the moon is between 11 and midnight. After that, you're going to be competing with the moon. So August 11th and 12th. And I'll be talking about this a little bit later, but there's actually going to be a joint presentation between the Montreal Center and the Ottawa Center tomorrow night, 8 o'clock, talking specifically about the Perseids, how to photograph them, and a little bit about where they come from. So I will talk about that a little bit later on tonight. Next slide, please. So here's the sunrise and sets. As you can see, the days are actually getting shorter as we move through the month. No surprise there. Mercury is not visible this month. Venus is visible before sunrise. We had the greatest western elongation, August the 13th, and you can look for Venus just before sunrise. And then Mars is visible before sunrise, and towards the end of the month, we'll be able to see it up in the evening sky along with Saturn and Jupiter. Jupiter is visible in the evening and through the night. Saturn is also visible in the evening and through the night. Uranus is visible before sunrise, and then in late evening towards the month end, and Neptune is visible all night. And there is our cartoon of the month. Okay, I'm going to turn it now over to Paul Klauninger, who's going to talk about imaging Comet Neowise. So just hang on a second here. So are you unmuted there, Paul?
I believe so. Can you hear me?
Yes, I can hear you. Yeah.
Super.
So I'm going to change my picture to his picture because he's turned off his video. There we go. That's the guy who's talking.
Thanks, Dave. Well, good evening, everyone. I trust you're all doing well out there. Well, what can I say? After the much anticipated but ultimately rather disappointing apparitions of comets Atlas and Swan this spring that I talked to you about, third time was a charm with Comet Neowise. As it turned out, this was the brightest comet visible from our location since Hale-Bopp way back in 1997. It was wonderfully visible to the naked eye last month under a dark sky and could even be seen within the city using binoculars. I originally planned this talk as a follow-on to the astrophotography workshop I did for our members back in March at Carleton University, and then concluded virtually on Zoom in May. By the way, those videos are available for download from our website if you're interested in digging deeper into the details that I'll be talking about this evening. So anyway, when Comet Neowise wound up being as excellent as it was, I thought I should change my focus and look at some of the challenges around processing comet images. Given the clear skies that we had on some of the nights during the optimal window, I know that many folks all over the world actually took their first crack at some astro imaging. So this seemed like a good opportunity to offer some tips and hints on processing, as well as share some of the images I was lucky enough to get myself. Next one, Chris. So this is Comet Neowise's discovery image taken back on March 27th of this year by the WISE Space Telescope. It's actually a composite of 3 infrared images, and at the time, the comet was only about magnitude 18 and out beyond the orbit of Mars. Next one, please, Chris. So this is the image that Dave was just showing to you as well. You can see the path that the comet follows across the sky plotted here. The rather dizzying portion, of course, that it appears to follow below the solid yellow ecliptic line is due to the Earth's revolution around the sun in the coming years. But the most significant part of the path is highlighted in red. The dots are position markers at 1-week intervals, and as you can see, they are spread most widely apart in July when the comet reached perihelion on the 3rd of July, and then when it made its closest approach to the Earth 3 weeks later on the 23rd. When you factor in the comet's height above our horizon, both before the start of dawn in the morning and at the end of twilight in the evening, along with the presence or lack thereof of the moon, our best interval to see this object actually occurred between July the 10th and July the 24th. It was visible earlier in July as well, but under the fairly challenging light of dawn. And it should also be visible well into August and September, but you'll need binos or a telescope for that point in time as the comet continues to dim as it moves farther away from us. Next one, please. So as the comet approached the sun, it became progressively more baked, and its ices sublimed to form an increasingly bright tail. This image shows that process. It was taken by the European Space Agency's Rosetta mission while the spacecraft orbited comet Churyumov-Gerasimenko back in 2015. A bright stream of outflowing gas can be seen leaving the comet. If a comet has substantial amount of solids in its composition, it can spread both a gas or ion tail as well as a fan-shaped dust tail. And comet Neowise has both of these. Next one, please, Chris. So this chart shows plotted observation magnitudes collected from numerous observers around the world. The gap in the middle of June is when the comet wasn't really visible here on Earth due to its proximity to the sun. As you can see, though, it was already showing a steady increase in brightness prior to that period, and that continued as it started to become visible again towards the end of June. The comet appeared to attain its peak brightness in the first week of July, and then the curve started to flatten and decline. The red lines are the 8 nights I observed the comet during the optimum 2-week window for our location. We were lucky enough to get some very clear skies on a number of those nights, and so if you found yourself under a dark sky during this time, the comet was a visual and imaging treat for us. Next one. So as I mentioned, this was the brightest comet visible in our sky since Hale-Bopp in '97, and so allowed imaging with even the simplest of equipment setups. And certainly when I think back of it, I mean, I was out imaging comet Hale-Bopp back in '97 using my Nikon FE film camera. And wow, a lot has changed in the intervening 23 years. Astrophotography has really seen a boom with the advent of modern digital cameras, and this has opened the door to astro imaging for many people. So again, I thought this would be a good time to talk about what people caught with their cameras and some of the difficulties that the comet presented to us in processing. But needless to say, even the most basic setups were available for people to use to capture some really nice images of the comet. And I've seen even some wonderful cell phone camera images, and wow, I'm impressed. Like that was a whole lot easier than when it was to shoot a comet back in 1997. However, this comet did present some challenges with lighting and the low elevation in the sky, and so virtually like virtually all astrophotographs, some processing can go a long way to mitigate some of those challenges. Next slide, please. So this image was sent to me by Terrace on July 4th. I was very jealous because at the time I wasn't at home. I was actually up in Northern Ontario and didn't have access to my equipment. So he sent me this image on July the 4th, and it's one of the earliest dates we could actually access the comet from our location. And again, just to stress the point, he took this with a very simple setup, a digital camera with a stock 50mm lens, with this camera on a tripod, and captured the comet in the early morning skies. In a 1.3 second exposure. So basically point and shoot. I really like this image because it shows some of the challenges involved in shooting this particular object. You can see that that dawn's light was obviously well underway here and brightened the sky considerably, but that really wasn't the only factor at play. Next slide, Chris. So the image was taken during the early morning hours, and about a week later, the comet started becoming visible in the evening sky as well. And from that point in time, the evening window became the best time to see it. But both of these windows presented similar challenges. For one thing, the comet was very low in elevation. Here in Terrace's shot, the comet was only a few degrees above the sky at the beginning of dawn. And what I noticed with doing imaging in the same type of interval and with the earlier comets that I mentioned is that you can image to about 15 to 20 minutes or so after the beginning of dawn or before the end of twilight. And you can notice a difference in the light levels, but it's not too difficult to deal with. After that, as the sun either gets closer to the horizon, either in the morning or the evening, it becomes a lot more challenging. The brightening sky conditions tend to wash you out with that as well. So again, comet was at very low elevation in this shot. And as with any astro imaging, when an object is close to the horizon, you get a lot of atmospheric attenuation and reddening of any light passing through from the sky, because that light has to travel through a much thicker layer of atmosphere at that low angle. So that tends to attenuate or dim the amount of light that your camera can receive. Also, one of the things a number of us noticed with the comets this year was that when they were in this low elevation state, there were often very thin but distant clouds hugging the horizon. And again, because the comet was sort of confined to that low elevation, it had to deal with those clouds as well. And again, this leads to a lot of different light gradients as well as attenuation of the comet's light. So, and after the beginning of dawn or before the end of twilight, the changing light conditions of the sun and the sunlight in the sky causes a huge variation in the background light levels of your image. And so an image taken during this interval compared with an image taken 5 or 10 minutes later or earlier can show a significant difference. And so they have to be dealt with often individually to try to get the best results. One of the things I also noticed was color gradients due to air glow. One of the things I really noticed was a significant amount of air glow on some of the clear evenings we had during our optimum window, but I'll get to that in a bit. Next one, please. So you can see here that this is an evening shot from July the 17th. Again, after about the middle of July, the evening window became the preferred one because the comet was steadily climbing higher into the sky by the end of twilight. And so greater elevation is certainly something that's pleasing to astrophotographers. The higher the elevation, the less air you're looking through, and generally speaking, the cleaner the images. But again, when I talk of high elevations, I'm still talking, around 15 degrees or less above the horizon. So you're looking through some very thick air. So again, the comet was at low elevation, similar challenges to the morning window, and you got increased attenuation and a reddening of the light. One of the other things that I noticed during a number of the evening windows, some of them were advantageous, but mostly not, was that there was a lot of air glow on some evenings that lent a really greenish cast to a lot of the raw images, surprisingly so, like much more so than usual. And again, you could see this vary over the course of the night because air glow does have a habit of changing over time. So and for those of you that don't know what air glow is, it's a dim glow in the upper atmosphere of the Earth caused by the recombination of atmospheric atoms that were photoionized by the sun during the day. It's usually most prominent about 10 to 15 degrees above the horizon, but when it's strong, it can also be imaged at much higher elevations. So unfortunately, 10 to 15 degrees or even less was where this comet was situated for a good amount of its time. So we had to deal with that as well. But next one, Chris. As you can see, just a little pop on the on doing some color balancing and some levels adjustments can go a long way to mitigate that air glow. Along with the air glow, July also presented some additional atmospheric challenges. As I don't have to tell you, we had a pretty humid bunch of evenings there in July and hot temperatures during the day. I found that this caused a general increase in the haziness at night when the atmosphere cooled down a bit, and this haze would, could linger over places where there was artificial lighting, and cause again lightening of the atmosphere at the lower levels. So also another factor contributing to gradients in the images that you have to deal with. However, it is what it is, and that's what we have to deal with. So next one, please, Chris. So in terms of processing, how do we get around some of these issues in our images? How do we go from the original image captured by our cameras to one that reveals the available detail and is a bit more pleasing to the eye? In the workshop video that I mentioned, we examined in detail some of the steps that we can perform in image processing applications such as Photoshop and the GIMP freeware. I obviously don't have time to dive into specifics here, unless Dave pulls the electronic hook on me. So here's just some basic recommendations that you can perform with essentially most image processing applications that are worth their salt. One point that I stressed in the workshop, and I think is worth repeating here, is that when you do image processing, it's really an artistic pursuit as much as it is a technical or scientific one. There's no specific right way or wrong way to do this, and the best result is one that pleases you and captures what you envision. So with that in mind, just as you process your images, results will vary, suit to your taste. All right, next one, please. So this particular image of the comet, I shot this with a 135mm lens, and what this shows you is the unprocessed raw image there. But you can see there's certainly detail in the comet there. It was also an early morning image. This is actually my first go at the comet on July the 10th. Early morning image there with the comet just a few degrees above the horizon, dealing with some of the same thin clouds that I showed you in Terrace's image. But you can see there's detail in the tail there, and so how do we get at that detail? Next one, please. Well, what I usually start to do with this, just hang on a second, please. Sorry, just had a bit of a technical glitch on my end. What I first like to do with these images is if required, I boost the level a bit so I can see a bit more of the details. And really, that's just like is stretching your histogram, giving a levels boost to bring up the light levels, and to maybe darken the base or the darker pixels. Just to give you a bit more of a spread in terms of the dynamic range that you capture and what you can see in your image. Dealing with color balancing as well is something that I typically do at this stage. So again, color balancing helps to eliminate some of that green cast that I mentioned to you. It wasn't too bad in this particular image. There was some there, but I found the morning images weren't near the air glow wasn't nearly as prominent and sometimes quite absent in those morning images, much more a prevalent thing in the evening. But color balancing does help to try to equalize that and get the sky looking the type of color that you want. Typically, blue once the dawn's light starts happening. I also tend to do some noise reduction here because what I do with comet images generally when I shoot them is I tend to shoot at pretty high ISO values, 1600 to 3200. The reason for that is that obviously if I'm working with a simple setup like a camera on a tripod, I want to keep those images as short as possible to prevent the stars and the comet itself from trailing over time. With wide angle lenses like 16mm or even 50mm, that's not so much of a problem. You can certainly shoot longer with it. But as you step up your focal length, 135 millimeters or 200 millimeters, whatever, that becomes more of a problem, and your exposures will start to show trailing much sooner. So I tend to want to keep my exposure short, and that means typically some noisier images. But again, with many image processing programs, you can apply noise reduction to alleviate some of that noise. Next one, please, Chris. So after I perform those initial adjustments, it's starting to look the way that I kind of want it to look in terms of the coloration. I see the nice reddish colors of dawn's light starting to light up the sky closer to the horizon. And then I still want to get a bit of a spread in terms of the brightness there. I want it to be darker in the top, which is what it is at that time of the day, but noticeably so. That helps also bring out some of the star details that are still visible, even though the light, the sky is starting to lighten up. So I tend to do a curves adjustment. That's again, for those of you that took the workshop, you're familiar with the curves adjustments that I mentioned. For those of you that are not, curves are kind of like levels adjustment, but they allow you to selectively boost or decrease light levels at different end of your histogram. In other words, they allow you to make the darker pixels darker without making the subsequent light pixels darker as well. And similarly, on the high end, you can choose to brighten things where it's bright, such as in the comet, without brightening the sky, which you want to be dark. So a curves adjustment in this case helps me to brighten the upper layers, still keeping them nice and dark with the stars visible, and the upper layers and the mid-level layers. I didn't want to brighten the horizon too much. I wanted to keep those cloud levels at that level. So basic curves adjustment allows you to do that. Next one, Chris. So for the final adjustment on this, again, I used a curves adjustment. Again, for those familiar with the term in Photoshop and in GIMP, a mask allows you to mask off a certain portion of your image and do adjustments just on that without affecting the rest of the image. So in this case, I masked off what I could see, the detail that I could see that I captured in the comet itself. And I played with curves and some levels adjustments to boost that comet image. As you can see here, if you compare certainly the last image here with the first one on the left, you can see that there's a lot more detail visible, including the blue ion tail of the comet, which was barely visible in the raw image. But the information was there, but you have to work at it to dig it out. So curves, a mask curves adjustment helped me to brighten the comet, and then I did a final contrast and brightness adjustment to increase the contrast of what I'm seeing there, but to keep it at a reasonable level so I don't overblow anything, either make the upper portion of the image too dark or the lower image of the portion too light. So again, it's a judgment call. It depends what you like and how you picture your image, especially with vis-a-vis with what you saw in the sky at the time that you took it. That's the way I usually like to play it. Okay, so those are the basic adjustments that really anybody can do to their images. And with the challenges of this comet, if you took images and you haven't tried these types of adjustments yet, again, pretty much any simple program, even most photo viewers will allow you some measure of adjustment. But certainly, if you want to get into it at a deeper level, certainly applications like Photoshop or GIMP, which is very much like Photoshop, allow you to dive into it much deeper and show some pretty and bring out some pretty cool details there. So with all that in mind, with these types of adjustments, these are the types of adjustments I generally performed on pretty much all the images. Well, I have to say all the images that I shot with my 16mm lens on a stationary tripod of this comet, the basic setup that I mentioned. So here's a few that I was lucky enough to capture. Next one, Chris. So this is July the 16th. I've left the technical details up in the top left corner there for anybody that's interested in the specs there. This one of the things I find with shooting certainly wide field is that you want to try to find a decent location where you can get some interesting stuff in the foreground as well, some interesting terrestrial things. The two best nights that I had of our window were July the 20th and the 23rd. They were dark, they were clear, and the comet was pretty much at its maximum height above the horizon for us on our location on Earth, pretty much at its maximum height at the end of a twilight, so at the beginning of true night. So that's what you want, get it as high as possible. July the 20th and the 23rd, that occurred at the comet was around I think about 17 or 18 degrees above the horizon there. So but sinking as the evening progressed because of the rotation of the Earth. So I tried to grab some of these images when the comet was at its highest at the end of twilight. So this is over Silver Lake. I went there twice, again on probably on the two best nights, the July 20th and the 23rd. And I was lucky enough to capture some pretty nice views of this beautiful object. Next one, Chris. This is also over a Silver Lake. This was on the 23rd, same setup, 16 millimeter lens just on a tripod. You can see in this image that compared to the last one, that there's certainly a difference in the sky there. There is some red auroral glow. This is low-level auroral glow, I believe. It could also probably be a air glow. There is reddish air glow, although it's more rare than the greenish stuff that we're used to. But you can see the sky is definitely different. It was still very clear earlier in the night, and even here. But there was this interesting aurora, which I'll talk about more in a second here. The thing I loved about this image, I had actually finished doing the imaging that I wanted to do, which I'm also going to show you here in a moment. And as I was packing up the equipment, we noticed that the lake had become exceedingly calm, much more so than it was earlier in the evening. There were ripples on the lake earlier in the evening, but as we were winding up our observations, the light breeze had died. The lake became exceedingly calm, and I actually managed to capture the comet reflected in the lake. So that was pretty much a lucky catch. I was hoping to move a little bit more to the left, but I would have wound up in the drink there. So I settled for that image there, and that actually helped block out some of the auroral glow that was behind that tree to the right. Next one, please. This one was taken on the 24th, the day after Silver Lake there. I went, this was actually right in the town of Almont, down at Gemmell Park on the waterway with the comet over the mighty Mississippi River. Okay, maybe it's not the same mighty one. It's mighty nice though. It's this is right in town in Almont there, and a brief exposure, just camera again on tripod there. July the 24th was really kind of the last time that we could see this comet without a moon interfering. So I wanted to grab this, and again, you can see a reddish cast through it. Again, because what happened on a couple of nights during this interval is that we had some low-level auroral activity as we had some particles streaming in from the sun, and it did cause auroras mostly at more northerly latitudes, but we actually did catch some here. Next one, please. You can see on this slide, this was taken on the 13th. This is the burnt lands just near Almont. This is one of the best nights as well. The 13th, the 20th, and the 23rd were my best nights, certainly. And on the 13th, we had this low-level aurora, and I was shooting a whole pile of frames, and on 4 of the frames, I actually captured some very faint red auroral rays. So this is the best of the 4 images, and you can see those rays passing pretty much right over the comet there. And again, this is a bit of a testament to the clarity of the air there. This was obviously, the comet is only a couple of degrees above the horizon here. and the sky was very clear. And I was really surprised with this aurora, a pleasant surprise. Next one.
Paul, it's Chris. Before I move to the next slide,
Yes.
someone has sent a question that it might have only come to me, so Dave may not have seen this.
Okay.
Your last three images were all 20-second exposures.
Yes.
And in a 20-second exposure, surely there should be a streaking of the stars, but there isn't one. How come?
With the 16mm lens, that's a wide enough field of view that you can shoot anywhere from about 30 to 45 seconds without seeing noticeable streaking, depending on where you're pointed in the sky there. Since the comet was relatively close to Polaris, the closer you are to Polaris, the less noticeable that movement is, because the evident rotation of the stars is less as you approach the poles and greater as you approach the celestial equator. So with the 16mm lens, this is why one of the reasons I really love this. This is my go-to lens for doing nightscapes like this, is that you can shoot fairly long on a stationary tripod and avoid that star streaking. Okay, next one. After that previous shot, that was in the evening of the 13th, and I was looking at the space weather site, catching the data there, and I saw that auroral activity was still actually underway. So after getting not much sleep, I went out in the morning, a few hours after that last shot, and to a different location, and I shot this image. This is only an 8-second exposure. Again, you can see dawn light there, but much to my surprise, on a few frames, again, I was capturing these red auroral rays, and you can see one of them on the left side of the image, just poking above the clouds there. So quite a pleasant surprise, and certainly a lucky catch. And even with this approaching dawn light, if you look at the comet itself, you can see the structure of the dust tail, and you can see the blue ion tail. Again, these are all untracked exposures using that 16mm lens, and just basic adjustments. They're single exposures, basic adjustments made in levels and in curves and in color balancing. Next one, please. So this one was on the 24th. This was right after I took the shot at the Almont waterfront. Again, there were reports of auroral activity happening for northern latitude observers. I didn't think I'd get anything, but as I approached home from Almont, I noticed there was glow in the low to the northern horizon. I thought, okay, is this what am I seeing here? I set up my camera, and lo and behold, you can see that red auroral band is actually quite extensive now. It seemed to have flared up there. Wasn't a lot of detail, but again, on a handful of images, I shot about 100 images or so before it started to dim. On a handful of images, I caught auroral rays, and voila, managed to catch one right adjacent to the comet. So again, a lucky catch, and I was very pleased to get that. All right, next one, please. So, in addition to the 16mm shots there, I also wanted to do some wide-angle shots, but of a longer duration. And to the question that I just answered, that requires that the cameras start to track the stars there. So if you want to go longer than about 30 seconds or 45 seconds or so, you do need to track it. And this is the rig that I used for those longer exposures with that 16mm lens. This was one of my, I wrote myself a number of objectives that I wanted to do while we had this comet in sight. And this was one of the objectives, was to shoot with the 16mm, but go much deeper so that, and track them so I could stack the exposure and just see just how long of the tail I could capture under a dark sky sight. So a mount like this was critical, and I'll show you what I got with that. Next one, please. So this one was taken also at Silver Lake on July the 23rd. This is a stack of 16 60-second exposures at ISO 1600. And when I processed this, I was really kind of blown away by what I saw, because that ion tail is nuts. I don't know, I hope you can see it on your screen there, but that tail extends pretty much to the end of the handle of the Big Dipper. That's like a 30-degree swath of sky there. So very impressive tail length on this. You can also see the fan-shaped dust tail pretty much filling into the bowl of the Big Dipper with some detail visible there as well. You can see some split in the dust tail there, lighter areas on either side of a sort of a dark vein running through it. So just a very pleasing experience to be able to shoot this. It certainly reminded me of Comet Hyakutake back in 1996 with its 40 or 50 degree long tail. And certainly I haven't seen anything of that like that since that point in time. So very pleasing and very lucky to capture this again on the 23rd. This was pretty much the night of the comet's closest approach to the Earth. And I count myself extremely lucky that we had such a nice clear sky to take advantage of it. And I'm certainly glad I went down to Silver Lake there. We had exceptionally dark skies there. All right, next one, please. So I got a couple more to show you there. I also, one of my objectives was to try to get more detail of the comet itself. And again, I had to step that up using use longer lenses there. But for longer lenses, you really need a mount that's more capable of lofting these things because they're heavier and they'll throw something like the Sky Tracker out of balance there. So these mounts, like the Star Adventurer, use counterweights, and you can put a much bigger payload on it. Next one, please. So this is an image of the comet taken at 80 millimeters. Sorry about that. It's a stack of 17 60-second exposures. Unfortunately, on this night, when I had planned this exposure, we had a bit of haze, at least out in my neck of the woods there. So it wasn't the clearest of sky available, but it wasn't that hazy. When you look at this image and say, well, where's the stars? One of the things I wanted to show you here is this is how I process images taken at higher focal lengths there. I separate the stars from the comet. That allows me to process the comet individually and then layer back the stars there. The reason that we do this as well is that even though these exposures are tracked, the other problem that you don't see with wide angle stuff is that the comet moves with respect to those stars in a fairly short period of time as it moves along in its path. So if you just take a bunch of images and stack them on the stars, you're going to get a blurred comet. And likewise, if you stack them on the comet itself, you're going to get streaked stars, even though you're tracking your exposure. So the best way to deal with this is to separate the stars and the comet, process them separately, and then remerge them. Next one, please. So this is the comet itself after just processing the same type of adjustments, the levels and curves, color balancing for sure. Some pretty extensive processing because it was a bit hazy that night. It wasn't the clearest night, but I certainly didn't think I could waste it. So it didn't turn out too bad. That would have been nicer if I'd shot this on the 23rd, but it is what it is. Certainly I caught the striations in the dust tail, which was really kind of cool. People were seeing this in other parts of the world as well there. Massively long striations at the rear of the tail there, also details in the blue ion trail. So after I finished processing the comet, I remerged it with the star images. Next one there, please. And that is my end result. So that's 80 millimeters, and it captures pretty much the full extent of the comet at that focal length there. So I was actually quite pleased with it, even though the sky conditions were not as good as the other evenings there. As I said, couldn't really waste any nights because there weren't that many of them available to us. Next one, please.
Paul, about 5 minutes.
Roger that. So these are actually the last couple of images that I want to show you. The other thing that I wanted to do was to zoom in. I really wanted, I'd shot a lot of wide angle stuff. And some medium focal lengths like the 80 millimeter, but I really want to get a close-in view of the of what's happening near the coma itself there. So with that in mind, I shot with a 420 millimeter lens, again on the Star Watcher. When you're shooting at this type of focal length, typically you want to couple an auto guider to it, as you can see here. This allows you to track with much higher precision and to do longer exposures without getting trailing. As you increase your focal length with any optical instrument, the tracking becomes more and more critical, because even a little bit of deviation from your alignment or from the tracking mechanism itself will cause your stars to become streaky. So 420 millimeters. Again, I shot this on the 23rd, which was one of the finest nights that we had in the window, and this is the same night that I shot the wide angle of the comet that I just showed you. Again, Chris, could you advance there, please? So this is the wide angle shot, shot on the same night with the 16 millimeter on the Sky Tracker. At the same time, I had the Star Adventurer running, second mount, and that was with the 420 millimeters. Next one, Chris. And what that shows you is the area that the 420 millimeter covers vis-a-vis the 16 millimeter here. So the 16 millimeter gives a nice deep view of the entire comet structure. The 420 millimeter allows me to zoom in and get close and personal and see what's happening. So next one there, please, Chris. And that's what I managed to capture with the 420 millimeter. I was pretty pleased with this. This was 10 90-second exposures. I shot a bunch here, and I picked the best 10. 420 millimeters. Again, process them like I mentioned before, doing the basic adjustments of levels and curves, color balancing, noise reduction as well, but process the comet and the stars separately and then remerge them. So as you can see close to the coma itself, you get actual ray striations in emerging from the coma, and details in the tail, let's say in the blue ion tail itself. Actually, you can see some of the reddening along that trail just near the coma. Apparently, this was due to the release of sodium atoms, which was confirmed by various professional observatories. Sodium atoms from the subliming material coming off the coma. So I was pretty pleased with that shot, and that is my highest resolution image of Comet Neowise. So again, just a marvelous opportunity to capture this comet. Next one, please, Chris. The last thing I want to show you is this short time lapse. Again, Chris, you can start that. Just click on it, please. This was shot on the 20th. Hope it's playing okay for you guys there. It's basically a camera, stationary camera. The 16 millimeter lens captured about 250 images for this, and it shows the comet just doing its thing in the night sky over Silver Lake on the night of the 20th there. It'll repeat itself. So again, this is something that you can do if you shot a sequence of images with your I don't know, I'm not sure if that's my bandwidth or not, Chris, but it should be cycling through again. You'll see that it's a pretty busy sky there. You'll see fireflies there, some of those greenish streaks, numerous satellites and airplanes passing through. But you can also see how the sky conditions change. I started this time lapse before the end of twilight, and you can see the sky is substantially lighter than it is at this point in time. And again, it goes to show you just how much variation you can get over a relatively short period of time in those sky conditions, and why you have to process your images with that in mind. Don't be surprised that if one image you take at a certain time and is vastly different from another one that you take 10 or 15 minutes later. So, but yeah, I like doing the time lapses there again, just to show you the motion there. And you can do this just by taking a bunch of images on a stationary tripod and then stitching them together in a video creation app, many of which are freely available. All right, next one, please. So just pushing forward. I took this image a week ago when the moon was up, very bright sky. This was only a week ago, and I was still able to capture this image. I was able to see it through the binoculars. And the reason I show you this is that starting tonight, actually, the moon is going to be starting to get out of the way when the comet is up, and it's and before the it's going to get out of the way by the end of twilight, which is nice. The comet will have faded a lot, but it should be visible in binoculars for some time yet, certainly for the next couple of weeks if you're under a dark sky. And you can do some imaging of it as well. Unfortunately, I don't think it's going to be available using a stationary tripod, but a tracking mount of any sort should be able to snag it. So I'll be interested to see if anybody catches stuff from this second window of the comet. Certainly won't be as spectacular, but hey, part of the challenge, right? So last slide, Dave, Chris. This just shows you where the comet is at this point in time. Again, starting tonight, it'll be in this neck of the woods there. You can see the Coma Berenices cluster is just to the right of it. Interestingly enough, when the moon is out of the picture and it's at the end of twilight occurs, the comet will actually be at a decent elevation, about 19 or 20 degrees or so, and as such, it'll be a bit of a treat for us in terms of its elevation. It will actually have climbed higher in the sky, but it won't be quite as bright, certainly, as it was in those spectacular weeks in July. So I look forward to seeing other images from folks tonight. I'm really looking forward to that, actually. And if anybody has any questions about either the workshop or just imaging these things in general, feel free to drop me a line. Thanks
okay, Paul, we got 2 questions for you.
Yep.
Brian McCullough is asking, how long does it usually take you to set up your camera gear and pack it all up at the end?
Depends. Those setups that I showed you, certainly on the Sky Tracker, which I use just for the simple 16 millimeter images with that lens, that's a very easy setup. I can have that up and running and polar aligned in like 10 or 15 minutes easily. With the Star Adventurer, it's a little bit more involved because it is a more complicated piece of equipment. But still, if I'm not doing auto guiding with it, if I don't have to set up the auto guider and do that kind of good stuff, I can usually have that up in polar aligned, again, probably 15 minutes or so. With the auto guiding, it takes a little bit longer because you have to do your alignment and calibration pretty precisely. So that can take a bit longer, but typically not more than about 20 minutes or so, 25 minutes. And to take it down is usually about half that time.
And from Douglas Fleming, how do you separate the comet and star images?
Oh, good question there. I should have mentioned that, actually. That is something that I do with Photoshop. You can do it with other image processing applications, such as GIMP or ones that are dedicated to astro images, such as PixInsight. But you can I'll mention Photoshop because that's the one I use extensively and most familiar with. You can select the stars using some of the tools in there by using things like the color range and brightness. And so you can select the stars out of each image and save them separately. And you can then, you basically can then delete them from the base image showing the comet. And when you stack the, so that gives you two images from the original, where you can get, where you have one plane, which is the star images, and the other plane, which is the comet itself. So by merging those planes, the different star planes from different images, then you get a combined stack of just stars and a combined stack of just comet. And again, keeping within the same file, then you just remerge them at the end when you finished your individual processing.
Okay, thank you, Paul.
You're more than welcome.
That's really great. And yes, we do have 1 or 2 images of the comets coming up in our observation section.
Super.
Okay, so we're going to move on then. Chris, the next slide, or 2 slides away, I guess. Okay, so talking about the Perseids, there's going to be a special joint event between the Ottawa Centre and the Montreal Centre, and that's going to be tomorrow night at 8 o'clock. And the information is there. I'm also going to be sending out an email to everybody who's on our distribution list with the links as a digital link, and I will send that out over the break. Okay. Next one. Okay, so we're going to take a 5-minute bio break here. This is our Messier and Moon challenge. So if you want to go to the next screen, please, Chris. Okay, so over the break, see if you can figure out what these images are, and the answer will be there in 5 minutes. See you then. Okay, folks, we're about ready to restart. So Chris, if we could get the next slide, please. Okay, so there's the answer to our challenge. We've got the Dumbbell Nebula and the Aristoteles crater on the moon. Okay, so Rob, are you ready to go?
Yep, I'm ready.
Okay, hang on a second here. I'm just going to highlight you. There you go. You're spotlighted now.
There, put me in the center.
There. Okay.
Okay, my presentation is about making a magnetic clutch. And this is something that goes back a long time ago to the 16-inch telescope. The 16-inch telescope was initially at North Mountain Observatory, was relocated to Indian River Observatory, which is now the Fred Lossing Observatory. And it has a large, it had a large sector arm, and to lock that sector arm to the declination axis, it used the magnetic clutch. Now, normally with a small telescope, you don't need to be so sophisticated, but the 16-inch was a pretty massive telescope. And so I just, when I built my 24-inch telescope, which is on the left-hand side, by the way, that's a picture from Rick Wagner. And since Rick is watching this, I thought I'd better mention his name. It's a 24-inch f4, f16, f4 Newtonian, and f16 Cassegrain. And for those of you who have been to my open houses or plan to come to a future one, then that's the telescope we'll be using. So the one nice thing about a magnetic clutch is that it can really lock the axes so that you can almost hang yourself off the eyepiece, and that you can literally move it with your little finger.
Rob, you're breaking up, so maybe if you could just turn off your video.
The configuration on my telescope.
So Rob, you're breaking up a bit on your audio, so maybe if you could just stop your video, and then it might be a little clearer.
Sure, I'll do that.
Okay, thank you. Oops, you're back. Your video's back on. There.
Oh, yeah. So the next slide shows you the configuration. Zoom in on the fork. There we go. And it's built inside the fork. The entire mount was handmade. And so it looks, it looks pretty beat up, but then again, it's 33 years old, but I can tell you it's still perfectly functional and actually very easy to use. Now, the friction clutch itself, it draws main power, which is about 110 odd volts, VAC. And it looks kind of messy, but again, it's something that was put together at the spur of the moment when I figured I really got to get something made. And I just, after 33 years, I just never changed it. So that's what remains. Now there's two parts to it. One is the mechanical part, which I'm not really going to talk too much about. And perhaps at a future time, I can talk about the subtleties of the sector arm. But the next slide shows you the circuit. Now the circuit's made up of actually a relatively few number of components. There's 3 transformers, commercial transformers, and they're take 110 volts, stop it down to 10 volts. And there's a center tap on it that gives you a 5-volt output as well. Added to that is a rectifying bridge. So that goes between the first transformer and the 2 second transformers. And that takes the alternating current out of the first transformer and makes it sort of an undulating wave, but all positive. And when I connected that up to my magnetic clutch, it had a definite 60 cycle hum, which literally was loud enough to actually bother me because I like listening to the crickets and the frogs in the distance, the loons in the lake. So I threw a capacitor in and that got rid of the hum. Now, when I initially put this thing together, I thought that using a 5-volt center tap off the left-hand transformer would be enough to give me a soft lock on the telescope. when it's not connected, when the left right hand transformers aren't connected at all, essentially the axes run free. When it's a hard up on 10 volts, then it's literally a hard lock. So I thought 5 volts would be nice in between. Well, it's not nicely in between. It was still very hard. So I put in a resistor and a high wattage resistor just to slow the current down a little bit so that I would have that nice smooth slide as when I wanted to move about the sky. So there's actually relatively few number of electronic parts. And as a mechanical engineer, I look forward to always making things as simple as possible. Now, on the right-hand side, those 2 transformers, they're mounted directly to the sector arm, and they're in contact with an iron disc that's bolted to the declination shaft. So when you power this thing up, the magnetic field from the right-hand transformers lock the sector arm directly to the declination shaft. Now, the next slide shows you how you get around to destroying 2 perfectly good transformers. On the far left-hand side, you see a typical transformer. The gray stuff are some metal plates that direct the magnetic field around, and then you got a blob that's in the center that has the varnished copper wire. There's actually 2 circuits in that blob of copper wire. One is a primary circuit that takes the high voltage, and then a secondary circuit that gets this lower voltage induced into it. Well, the way this is put together is that it looks actually like a figure 8, but the way they manufacture it is to have 2 sets of plates. Some look like E's and the other ones look like I's, and they interchange and stack up, and everything gets fit together. So the trick is then to take, again, this perfectly good transformer, in my case 2 of them, and you break it apart by removing these metal plates, and then you separate them out and you stack up all the E's into a stack, and you shove them back inside the transformer, and all the I's you put away in your drawer for some future project. So what you end up having is the open ends, or I guess the 3 open ends of the E, then are the form a plane through which the magnetic field is going to loop out of the transformer and into the metal plate. Now, the next slide shows you kind of what the magnetic field looks like. Actually, there's a mistake here, so I'll just point out the mistake so the electrical engineers don't send me emails. Those arrows coming out of the transformer, they should actually be in the same direction, and the opposite direction arrows go up the center. But initially, the magnetic field is trapped in those metal plates, and by taking the eyes out, the magnetic field can now loops up and out of the transformer. Now, in the lower right-hand corner is a typical circuit for a transformer. You have the primary circuit on the left side, and that's maybe the 110 volts alternating current. That goes through the primary set of wires, and that induces a magnetic field in the metal plates. And the magnetic field goes around to the secondary circuit, and as the alternating current in the left-hand side goes up and down, the magnetic field goes up and down, and the changing magnetic field induces the current in the secondary circuit that turns on your light bulb, whatever. And depending upon how many loops of wire you have in each side, you can step the voltage down. In my case, step it down to about 10 volts. Now, we don't need an alternating current in this. We've already got one transformer that stops the voltage down from a dangerous 110 volts down to a quite benign 10 volt. But we don't really have to we don't have to generate an alternating current in the secondary circuit. So we just need a direct current, and so that's why I've rectified the primary circuit on the left-hand side. The next slide, or the next frame in this slide, is by ignoring the second circuit and by taking the eyes out of the eye metal plates out, we end up breaking the magnetic field. So again, it loops out of the transformer and into my metal plate. And so it is kind of sad to destroy two perfectly good transformers, but many people in the group that know me know that I just love to misuse perfectly good equipment. The last slide shows you a detailed shot of what the main clutch portion looks like. And you can see top center, you've got the metal plate that's bolted onto the declination shaft. To give you an idea of scale, it's about 8 inches across, about 20 centimeters across this frame. And the fork itself is 1/4 inch steel, so it's quite a massive telescope. It's about 1/2 a ton. I use the aluminum sector because it was easy to make. And then I take the metal strapping that's off the transformers. I had to take that off so I can access the metal plates, put the strapping back on, and that let me mount the modified transformers directly to the aluminum sector arm. By the way, right in the center, you see a really, really rusted nut, and that's the actual center of the axis of declination. So the sector arm is centered on that bolt that goes through the sector arm. And you can just barely see the rectifying diode module right at the bottom, just half off the screen. So it looks kind of dangerous with all these terminals sticking off, but really it's only 10 volts. And when I have a longer cable that goes to an ordinary switch, two-way switch, so I can switch from off, in other words, open circuit, the magnetic clutch is off, and I can just literally pull the telescope anywhere around the sky. I flick the switch once, it's on a soft lock, and then I can switch it again, and that goes onto a hard lock. Generally speaking, I almost never use the hard lock because I kind of like, I like pulling the telescope as I'm looking through the eyepiece, just scanning the sky. In fact, you can see some of the wear marks on the steel plate or on the steel disc. And the rust really doesn't matter too much because if anything, it just adds a little bit more friction. So it's been working quite well, again, for 33 years. And it certainly looks like it, but it works quite functionally and literally hasn't given me any trouble. And if you have any questions to get more information, by all means, send me an email and at rdick@cspg.ca, and I can try to fill you in.
Okay, thank you very much, Robert. I don't see any questions at this time. So we're going to Hugo. Are you live there? Okay, you just need to unmute yourself there, Hugo.
There, can you hear me now?
Yes, you're good.
Okay, I'm on. Okay. Right. Next slide. Yeah. Recently, there were some queries on the RASC blog about commercial cell phone adapters, and that aroused my curiosity. I didn't know such things existed. And I recalled that Brian showed an image that he had taken with a cell phone some time ago of the moon. And the image was terrible before he got it processed. And after that, it was half reasonable. Anyway, so my curiosity was aroused. And I thought, well, let's see what I can do. Next slide, please. So I thought, well, why don't I just make up a little jig and I can put my cell phone on and move it over to the eyepiece and see what happens. So basically, all I did was take a board, a small board, drill a little hole in it so that I could put it on a rod that's attached to the telescope. And then I put two little wooden rails to it so that I could slide the cell phone into that guide. Now, one of those holes I didn't put a nail in so that it would open up slightly so the cell phone would go in more easily. And then to hold it in place, I simply put an elastic on. Next slide, please. Yeah, so it's simply a small wooden board and just a hole for the supporting rod, wooden rails, Okay, and then I just use an elastic to clamp it in. Now then the rod allows the phone to be swung over the eyepiece. Next slide. And you can see here where it's been swung over to the eyepiece. So next. Okay, so the equipment that I was using was a 6-inch telescope, a Newtonian telescope, just mounted on just a small equatorial mount. And this telescope came about from a draw that was held at one of our RASC meetings. And I picked this up and I thought, well, my son doesn't have a telescope, so maybe he can make use of this. So it's somewhat a telescope of questionable pedigree, and I really didn't know, what good it would be. So, and the cell phone that I was using is just an ordinary Samsung cell phone camera. It's got 8 megapixel resolution and of course autofocus and exposure. Now, I'm a total klutz when it comes to cell phones. It just doesn't like my finger, for one thing, in spite of the fact that my background is in engineering. So I'm not quite sure what I could expect. I was hoping I could get something, since there was some hope. Next slide, please. So I put on a night of the 28th, we had a clear view of the moon, and using a wide angle eyepiece, which is a long eye relief, I managed to line things up, and I clicked on the on the trigger of the cell phone, and that's what I got. The night after, next slide, you can see the terminator has moved along, and again, it's not that bad an image at 50 times, and it's surprising actually. Now when I looked at those images, how some of the really big craters almost disappear when the terminators move further on. Then that second night, I got a little more ambitious. Next slide. And I thought, okay, I'll try it at a higher magnification. So this is at 100 times with a 12.5 millimeter eyepiece. And with that eyepiece, it's a much smaller field of view. And you got to get your eye really up close as opposed to the other one. And of course, at the higher magnification, everything is a little more sensitive to the touch. But again, I think it's okay. I snapped a few pictures with the cell when I lined it up. Now, one thing I did notice is that the field of view, the sharpness wasn't the same across the field. But if I moved the image over to the other side of the moon, I got that end sharper. So I could combine if I wanted to make a big image. And as you can see, some of the quite small craters are actually quite sharp. Now, next. Now, there's a number of issues when you do these. The first thing is, okay, because you're touching the adapter and the cell phone, you're going to jiggle things. So if you've got everything lined up perfectly by eye, you're looking through the eyepiece, everything's perfect, then by the time you move things over so that the phone's camera is over the eyepiece, you probably jiggle things away from the object, or at least somewhat. And and there's no, like in terms of centering, the lens of the cell phone, it's just a little, if you like, a little window in the cell phone. So there's no kind of alignment mark or some guide that you could kind of click things into. So it's bound to shift a little bit. So that's a little tricky. And then of course, to turn on the camera, you've got to push the camera, you got to touch it. And again, you introduce jiggle. Now, when you take your actual image, okay, you have to push the trigger, the shutter mechanism, okay? Well, I found out that it would actually trigger, if you're careful, without actually touching. It's just a hair above the surface and it'll trigger. And the shots that I took of the moon at that night, I was too eager to see if I could get anything at all. So I completely forgot about the fact that there is a delay feature of a couple seconds or 10 seconds in the phone. So you could touch it and it will go off after it stabilizes. Or actually, I also found out that it has voice control. Even better, you don't even have to touch the thing. And of course, the other thing that I was concerned about was the moon's quite bright. Is it going to be totally washed out? Will the exposure be right? And that's the first thing I thought about actually was focusing. Will the darn thing focus? Even if I focus with my eye, will the cell phone have enough intelligence to focus on the moon? Well, I kind of fiddled a bit and got on a Terminator and pushed the little screen there. Got the little green window, and it seemed to be okay. I wasn't sure. So I took a number of images. I could see a few craters in the cell phone, and I thought, okay, well, something's going to turn out. So I didn't really know what I would have until I transferred the images to the computer. And out of, well, what did I take? Maybe 30 images or so. I did get maybe a dozen that were quite reasonable. So now I said, okay, if I can do that, if we go to the next image, and what do we have here? I got really bold and turned my telescope last night, in fact, onto Jupiter. And lo and behold, I could see, I hope you can see on your screen, there are 4 satellites. One of them is very close on the left-hand side. It's almost washed out by the glare. And the faintest one is on the far right. Yeah, so the left-hand one is almost at the planet there. Now, so for that, okay, I was wised up now. So I said, okay, this time I'll use voice control. So here I was in the front of my house in total darkness with my telescope, shouting into my cell phone, smile, smile, smile. Now, if anybody was walking by, they'd wonder what the heck was going on. Anyway, 70% of the time when I said that, the shutter would go off and it would take an image. So of about, what was it, 30 or so images, about a dozen appeared to show some of the moons. So of those, I took the best 3 and superimposed them on to make this image. So I figured, well, gee, that's surprising. That's pretty darn good. But I shouldn't be surprised because today's cell phone cameras are the highest technology we have today. Okay, set 2.
Thank you very much, Hugo. And I don't see any questions pending right now. So we're going to move into our observation reports. So first person up is Brian. So are you ready to go there, Brian?
Yes, indeed. Okay. Brian Carroll, just a quick introduction. I know some of you from Star Parties, and also I've interviewed a few of you and some of our presenters for the local blog Apartment 613. And that was in the before time, and now I can't go to Star Parties. So I was looking through my scope and saw this view of Montes Apennine. Yeah, I give up. It's the Apennines, and realized that if I was at a star party at the Aviation Museum, I could just have kept this in the eyepiece, and I'd have had people lined up for hours going, oh, wow, just looking at this. And now I can't even show it to my neighbors across the street. But Paul Klauninger said, try out astrophotography. So I did. This is shot with an 81 millimeter William Optics refractor. I'm using an 8 millimeter Teleview eyepiece projection. It's an old Canon 30D, shot at 1/30th of a second at ISO 3200. And the same night as Hugo's picture, July 28th. Next slide, please. Okay, so if you're new to astronomy or if you're new to lunar astronomy, one way that you can find the Apennines is to look for three big mare. There's Mare Imbrium, Mare Serenitatis, and a smaller one, Mare Vaporum, and the Apennines split those mare from each other. It's also a nice guide to some decent craters, working left to right: Eratosthenes, Timocharis, Archimedes, Autolycus, Aristillus, and Eudoxus, and there's Manilius down near Mare Vaporum. So I've sent these two photos to some friends, mostly people who are not astronomers. And one of my friends from Calgary, who's recovering from a very bad bout of COVID-19, responded back with a thank you, saying that they made her day. So Paul Klauninger, you made my day. And that's the end of my story.
Thank you very much, Brian. Those are super pictures. Okay, so next up we have Calvin.
Okay, so I'm Calvin Klatt. I'm a new member. I saw my name at the beginning there that I had recently joined. I joined in April. I guess I've been doing astronomy off and on since I was a really small kid. And I've sort of been doing astrophotography now for about a year. I guess I should say that I want to say that the biggest telescope I've ever used is a 300-meter diameter telescope because my education is in radio astronomy. So I observed with the Arecibo Observatory in 1985. But anyway, so 300 meters, that's my biggest diameter telescope. And now I work in a field called geodesy, which has been associated with astronomy for a couple thousand years. So this is the comet Neowise, and this is actually not far from where we saw those other photos. This is from the Bon Echo Provincial Park area. So over Mazenod Lake on the 24th. The 24th was not a good night. There was quite a bit of cloud and a fairly bright moon that was lighting up the cloud. I was with the Alpine Club of Canada, which is a climbing community there. I was a volunteer boat driver / rescuer. And I had, there were a dozen rock climbers at our facility there. And I managed to get all of them to see the comet with the naked eye. It's quite a dark sight, that area. So that was quite an accomplishment to get the 12 climbers to all see it. And then I retreated to my campsite and I took this shot. This is, I'm actually tracking it using a Skywatcher Adventurer mount on a small tripod. And I'm using a Canon kit lens. So that you see the coma in the corners. That's because I have a very cheap lens here. But it worked well, I thought. And I thought it's a nice framed on a tree just at the campsite there. You can see the blurring of the foreground objects because I'm tracking the stars. So I think that's it. We'll move on to the next one. So this is also a comet. This is actually taken in May 24th from my cottage in La Pêche, Quebec. This is Comet Pan-STARRS. I was actually struggling to get my equipment to work, and I looked over towards Bode's galaxy, which we see on the left there, and the other cigar galaxies are Messier 81 and 82. And I looked over at Bode's galaxy, which is relatively bright and familiar, and I noticed this strange object in the side beside it. So I had to figure out what it was. It was obviously a comet. I figured out that it was Comet Pan-STARRS, or C2017 T2 Pan-STARRS. And I basically left the telescope running through the night, tracking the field here. So to produce this image, the comet was, so I'm taking 30-second subframes and stacking them. So there were many hundreds of subframes. So when I stacked them two different ways. One, I stacked based on the comet, and all of the other objects were blurred. And then I stacked based on the stars, and I got the comet as a streak across that. And then I merged the two using, I guess, GIMP. I used GIMP to merge, superimpose the comet on the other field. So I like the image. I like the Bode's galaxy. I think looks really nice in this, and it's pretty good signal to noise running through the night like that. And yeah, so comet, different comet, but following the theme of comets. So this is with the RASA 8, the Roe Ackermann Schmidt astrograph 8-inch. Has quite a big field of view. And the camera's a ZWO ASI 294, which is a one-shot color camera. Costs about 1,500 or a little bit less than that Canadian dollars. The focal ratio of that RAS is f2. Okay, so on to the next one. Forget what the next one is. Can we see the third image?
You seem to have a bit of a time delay there. It's the Veil Nebula.
Okay, maybe it's too big. Yeah, so actually this is the Veil Nebula, or will be soon the Veil Nebula. This is with that same RASA camera, but this time I added the ZWO dual band filter. So it brings out, we're not seeing the, well, I'm not seeing, maybe I should remove these pictures. Oh, and I guess we do see, yeah, I didn't see the witch's broom on the right. So yeah, so the Veil Nebula, I think we've all probably seen this before. For me, this was actually an experiment in using that dual band filter with a one-shot color camera. And also it's an experiment for me in terms of merging. There are two images merged together here. So I took a shot of the East Nebula and the West, and I merged them together. And I think that the triangle in the middle is the Pickering triangle, and it really came out well with that filter. And I think it's, so I'm fairly happy with this image. And what's interesting about this image is it's actually about, because it was an experiment in merging, there's about 15 minutes of data on each side. So the total amount of data is about half an hour. It's the power of a f2 telescope. So I think that's it for me. I'll move on to the next guy.
Okay, thank you, Calvin. Okay, next up is Jim.
Okay, thank you. So these are some summer treats that I never get tired of. This is M20, the Trifid Nebula in the constellation Sagittarius. And this is a combination of an open star cluster, an emission, reflection, and a dark nebula all in one. This image was taken with an 80mm refractor and a Malencam Skyraider DS10C. No filters were used in this image. I had a chance to be at a dark site out of the city a couple of weeks ago, and I'm pleased with the vibrancy of the Trifid in this image. This is a stack of 10 8-second exposures. Next slide, please. And this is M16, the Eagle Nebula in Serpens, approximately 7,000 light years away. And this was taken with an 8-inch Smith-Cassegrain and the Mellencamp Sky Radar. This is a stack of 10 18-second exposures. The Optolong L-enhanced filter, which brings out the hydrogen emissions, was used here. Next slide, please. This is the Helix Nebula, NGC 7293, and it's a planetary nebula located in the constellation Aquarius. I read that the Helix is one of the closest to Earth of all bright planetary nebula. Its distance is approximately 655 light years from Earth, and it spans 2.5 light years. This is a stack of 10 22-second exposures. Next slide, please. And this site should be familiar to you. It's M8, the Lagoon Nebula, which is a huge H2 region in Sagittarius. Visually, it's about 3 times the size of the full moon and about 110 light years wide. This is a stack of 10 18-second exposures. I use the L-enhanced filter with this image, and I'm pleased very much with the color range and detail. As you can see, the nebula contains a number of Bach globules, and these are isolated small dark nebula containing dense cosmic dust and gas from which star formation may take place. And Bach globules are commonly found in H2 regions like the lagoon. Thank you very much.
Thanks, Jim. Now on to Rick Wagner.
Hi. I just wanted to start off by saying how much I miss our in-person meetings, getting to see everybody. But on the other hand, during the break, I was able to pop out and open the observatory and get the telescope ready for observing tonight. And I'll also coincidentally be running the RASC remote telescope in California all night tonight on behalf of the science team doing some photometry. So first image, I thought this was a kind of a nice image. It's basically been scooped by Jim with the Trifid and the Lagoon. This is a series of about 130-second exposures. I was running on a mount that wasn't very well polar aligned. And so I basically had to keep the exposures kind of short. So whatever that is, 45 minutes or 50 minutes total time. The M20 is one of the unusual nebulae in the sky in that it's a combination of the reddish H alpha emission and bluish reflection of starlight off of dust in the area. Above, sort of top center there is M21, the open cluster, and then down in the bottom left corner is a globular cluster, NGC 6544. What's really interesting as well in this area is you can see that from place to place in the picture, there's a huge variation in the number of stars. And that's not actually a variation in the number of stars, it's actually how much gas and dust there is that's in front and obscuring the stars behind us or behind the dust. So you can see that the areas where the stars are most dense, they also tend to be dimmer and redder. That's because we're seeing them through gaps in the dust clouds extending further towards the center of the galaxy. The other thing that I thought was really interesting about this image is this is my first attempt at stacking images with a program called Siril, S-I-R-I-L, freeware, available for Linux and Windows. I've had it for years, and it has a somewhat counterintuitive or non-intuitive interface. So it took me a few tries before I decided to make the effort of finding some online help and using it. And I found it tremendously easy. Stacks beautifully, it's reasonably quick. has color balancing and various other image enhancement. So basically, a few minutes goes from 100 images to a single stack like this. Next, please. So of course we have to see the comet. I was out 2 mornings. The observatory was out open and running. The Boltwood scope I have all under computer control, so it does scripted observing. So about 2:30 in the morning on the when was that? The 10th. You can't see the comet from my house. That's my house in the bottom right corner. So I canoed off to an island out in the middle of the lake with all my gear, equatorial barn door tracker, power supply, inverter, cameras, lenses, batteries, binoculars, and lugged it all off onto this little island and discovered that the battery was not charged enough to actually drive the inverter. So I was stuck doing basically just tripod mounted shots. So this was 10-second exposures with an 18 to 50 millimeter f2.8 lens, shot at 40 millimeters, probably 8 or 10 shots combined for this one. One of the advantages to going out in the morning like this is it's very quiet. And while the camera sits there taking pictures, I was able to go off and fish for an hour, swim for an hour, canoe for a half an hour. So I kept busy while the camera did all the boring work. Next, please. So this is a 100 millimeter f2.8 shot. I went up to ISO 6400 and 5-second exposures to minimize the amount of trailing since they were tripod mounted. And you can see the plasma tail is showing up quite nicely on that one. So that was my last time attempting it in the morning. Oh, no, sorry, that was in the evening on the 14th. At that point, I decided rather than trying to stay near home and canoeing everything out with batteries that don't work, I decided to drive to another location where I could use the car's battery. So next, the following pictures are all with the barn door tracker. And this one was from a farmer's field out east of Westport. 70 millimeter lens, 70 to 300, shot at 70 millimeter f4, 8 times 2 minute exposures. You can start to see some nice wiggles in the plasma tail and some variation in the dust tail. You can see that notch that Paul was talking about. Next. So this one is a similar image, 70 millimeter f4, stretched a little bit, makes it a little less attractive image, but it does show the details in both tails a little better. So that was kind of interesting. I'm going to have to try Paul's technique of, these are all just very simple processing, minimal contrast enhancement, stacking of a dozen or so images. Next, please. So this was a 300 millimeter shot on the barn door tracker. And one of the things I liked about this is it also shows some detail in the plasma tail, but it's also beginning to show the greenish cyanogen glow around the coma. That was not, I didn't find anyway, it was at all apparent previous to this date, and it became more and more significant as time went by. Next. So I saved the prettiest for last. This is back to the evening of the 14th, tripod mounted, probably total exposure of maybe 100 seconds over the lake. So it was nice to catch the reflection. Naked eye, you could see the gas tail and the dust tail both very easily, even in the reflection from the water. So it was a lovely lovely evening to see the comet. And that's all I have.
Thank you, Rick. Bob Olson, you are up next.
Okay, this is a picture of the comet on July 17, and it's just a snapshot with my camera mounted on a tripod, 10-second exposure. It was in the evening. I don't do mornings, so it was low in the twilight, visible to the naked eye. It didn't look a lot. It didn't look very much different than what you see in this picture. It was quite visible, and it looks really spectacular in binoculars. Next picture, please. Now, finally, on July 30th, the comet got high enough in the sky in the evening that I could see it, because my observatory is blocked in the low north. And so I got my telescope on it. And this is, what do we got here? It's 15 RGB individual images, 100 seconds each, all stacked. And it's at a 1350 millimeter, so it's pretty tight in to the center of the comet, the head of the comet. And you can sure see that green color. When I first saw that, I thought, this is a mistake, but the stars are white, so the color is probably correct. Okay, next image, please. This is M4. It's one of the challenge objects, and it's very low in the sky in Sagittarius. And as a matter of fact, it's so low that I can only see it for an hour between trees. And so I took this over 3 days, so it's 3 hours of exposure. It's the closest globular to us on Earth, but it's still 7,200 light years away.
I had a question regarding the Neowise image. The previous one said, why is there red there?
No idea.
Okay.
Sorry. I did not do anything to the image to make it red.
Okay.
Anyway, next image, please. This is NGC 6503, and it's a spiral dwarf galaxy. You can see the spiral if you look at it a little bit. It's an edge-on, sort of, tilted just a hair. And it's 17 million light years away, which is relatively close for a galaxy. Okay, next image. That's also a challenge object, by the way. And this is also a challenge object. You'll probably be surprised to know its nickname is the propeller. To see this visually, you'd need an 18-inch or larger scope. And it's in Cygnus the Swan. And when I went to do a little research on it, the information was not much is known. So it's I'm assuming not a heavily studied object. Clearly, it's hydrogen gas being ionized by some nearby stars. Okay, next image, please. This is NGC 6946. It's had 10 supernovae in the last 100 years, and it's had 4 in the last 10 years. So it's called the Fireworks Galaxy. I always thought it was called the Fireworks Galaxy because it's got these red hydrogen alpha areas, I guess. It's 22 million light years away. It's 1/3 the size and has half the stars of our Milky Way. And it's dimmed 1.5 magnitudes because we're looking at the dust. It's on the galactic plane of the Milky Way, and we're actually looking at it through dust. And if you look closely at this picture, you're going to see a ton of noise. So this is a picture that absolutely needs more time, more exposure to get a good picture of it. Okay, thank you very much.
Thank you, Bob. Next up is Raymond.
Hi. Hi, Pierre and I went to a private property near Low, Quebec. And this is my photo of the evening of the 17th, just when it was getting to sunsetting. It's an 80 millimeter at f4.5 for about 5 seconds, ISO 3200. Next slide. Well, this is my take of changing it to black and white and trying to enhance to see how much of the tail has been stretching out. But also I saw on the left a little meteor shot that night. So I had a sporadic going near the meteor and the comet together. But you can see how high, and I guess, and with everybody else photo, the tail is extremely long. Next shot. This is my take of trying to take the comet with a reflection of a lake. If you look at the lake, you'll see how the head of the comet is green. It's just at the below middle left of the image. You could just see the green tinge on it. That one was taken with a 70 millimeter lens at f2.8 for about 20 seconds at about an ISO 5000 at approximately the same location. Thank you.
Okay, thank you, Raymond. Okay, Taras, you are up. You need to unmute yourself.
I just did. Can you hear me?
Yeah.
Okay, so this is the picture which Paul showed. It's one of the first picture I took on July the 4th. That was actually the morning right after our last meeting in July. So I haven't slept that night. I took my camera and went to Antrim, small hamlet near Highway 417 near Almond, and there is a wide open field where I took this shot around 4 o'clock. As Paul mentioned, this was again 4 o'clock, quite bright. There was one of the earliest possibilities to see the comet, and this was 1.3 second exposure at ISO 100. What's interesting, I have similar pictures to this taken just 10 minutes earlier, and it was so dark, well, relatively dark, before the time that the exposure would have to be 3.2 seconds at ISO 400. So what Paul was saying about the environment, how quickly it changes, how quickly the amount of light changes, that's an example of that. Let's go to the next slide. And this is the close-up. Again, the same location, almost the same picture, but this, as far as I could have gotten the details of the comet with a tail, which wasn't that big and brightly expressed in terms of ion tail back then. What's also interesting, there is no greenish glow in a comet at all, that at least that early around, again, July 1st. Let's go to the next slide. And this is the same Silver Lake. So this was July 9th when I took another shot at the comet. This was much better opportunity because the comet was rising a bit later. So I started taking pictures around 3:30 a.m. when the sun was just about to rise, but still was rather dusk time and dawn rather. And you could see a little bit of smoke, fog above the water. And I'm happy with the fact that stars show up quite clearly on this picture. Let's go next slide. And again, the same location, a bit of a close-up. Not much of the green shows, but the tail is quite bright, and it was getting brighter and brighter because not because the comet was getting brighter, but because the earlier rise hours. So the background was getting darker, so the contrast was higher and the comet seemed much brighter, which, next slide please, was clearly seen on July 14th. So that night I went with Konstantin Popov to the same Antrim place where we took this picture, so that Star Adventure at the bottom lit in red, that's him taking picture from that location, and unfortunately we had a little bit of a cloud obscuring the rest of the tail. But if you wait a little bit longer, which I did, so let's go to the next slide. The cloud was gone, and I was able to actually, this was one of my best shots, because in terms of performance between the brightness of the comet and the darkness of the sky, I think the balance was the best. I made this picture exactly the way how Paul described it, but from the stars by creating a mask. So use the mist on the skies with the relation to the stars. So if I stack on a comet, then the stars will get star trail.
I think we might have lost Taras. He's dropped out. Yes. Okay. What we're going to do, Chris, let's move on to Oscar. And then if Taras can get back in, he can finish the last two of his shots there.
All right. So I've been up here presenting an image in a long time. I've had a baby since, or my wife did. So I've been quite busy. I haven't had a chance to go to imaging. I took this particular image here on the night of July 17th, just out near my place. So this, interestingly, was taken with my iPhone 11 Pro in night mode. So you can see it picked up a little bit of the comet. I was quite surprised actually that it picked up anything at all. But quite pleased considering I was just standing in a field and pointed my phone in the general direction, and it managed to capture a thing. All right, next slide, please. All right, so this was taken on the night of July 20th. I went out to Silver Lake with Paul. This was a stack of 30 shots. I believe there were 30 seconds in length each. So 30 by 30 at 50 millimeter f2. So you can see I got some of the ion tail there and some of the dust. I wasn't super pleased with the way the contrast worked out in this picture, but my imaging processing is a little rusty, so I've got to work on that a little bit. All right, next one, please. And this is my last image. This was taken on the night of the previous one was actually taken on the night of the 23rd. This one was taken on the night of the 20th. This was using a Canon 200 millimeter lens at f2 on a stationary tripod, 3-second exposures at ISO 1600 using a Canon 1100 EOS 1100D. So I was pretty pleased with this image, especially with some of the detail I got in the ion trail there. So that was pretty cool. So did I mention this was on the 20th as well? Paul and I went out to Silver Lake. There was quite a wonderful night. Beautiful comet, both visually and through the camera. So I was glad to be able to make it out, and big kudos to my wife for covering me on baby duties to allow me to enjoy the comet. All right, that's it for me. Thank you.
Okay, thank you, Oscar. We're going to just jump back to Taras, who dropped out there. We've got a couple images left there, Taras. You need to unmute yourself. There you go.
Thanks. Yeah, I didn't realize the connection was so bad. So yeah, this was a stack of about 10 pictures where the background was stacked separately from the comet. And there is a little bit of green showing up now in the comet itself. Let's go to the next slide. Next slide, please. This is the close-up of the same picture. I just cropped that area to show that green glow, which was intensifying with time, and this was the date when it was quite noticeable that night. Let's go to the next slide, please. And a few days later, so this was already on 20th, if I'm not mistaken, July 20th, when we went with Andrew Brown to the Morris Island. This was a little bit different story because the comet wasn't that bright, so the contrast on the picture is lower. However, the green glow is more prominent. So if you happen to look at the comet right now through the telescope, especially, I think that green glow caused by cyanogen gas will be quite noticeable and overtaking, I guess, the glow from the tail. Let's go to the next slide, if any.
No, that's it.
I guess that's it. Thank you.
Okay, thank you, Taras. Okay, so we'll just move forward here with the slides. Okay, so our observing challenge, oh, hang on a second here. There we go. So our observing challenge last month was M4 NGC 6503. The advanced challenge, intermediate challenge was NGC 6503. Advanced challenge was Sirius 57, and lunar challenge was Crater Wohler. Okay, next slide. So our beginner challenge this month is Messier 55 as a globular cluster in Sagittarius around 6th magnitude and 19 degrees in apparent size. Next one. Intermediate challenge is NGC 6826. It's a planetary nebula in Cygnus. It's known as the Blinking Nebula. It's 8.8 in magnitude and 27 seconds in size. And the advanced challenge is IC 4732, planetary nebula in Sagittarius, 13th magnitude in size and 10 seconds in size. And our lunar challenge is crater Eratosthenes. Hopefully that's correct. Anyways, lunar impact crater located between Mare Imbrium and Sinus Astium Mare. It's 59 kilometers wide, 3.6 kilometers deep. All of these challenges will be in the upcoming Astronauts, so you can take a look and revisit them there. And there we go. So I'm excited to say that for our next meeting, we have two guest speakers from out of town. We've got Dr. René Doyon, who is one of the Canadian partners in the James Webb Space Telescope. He's going to be talking about the Canadian contributions for the James Webb Telescope. And the other person I've got next month is Dr. Christian Sass, and he is the leader of the iTelescope project. And you'll find both of these talks quite fascinating. And you'll also notice that we are on the second Friday, because the first Friday is the Labor Day long weekend. So September the 11th, 7:30 p.m. Okay. Next slide. Fred Lawson Observatory is open to members of RASC. We need to make sure that we respect social and physical distancing rules when we are there. And unfortunately, our library is locked up in the museum. At some point, hopefully we'll get back there. Okay, and here are the various folks that work to make our club run smoothly. Okay, next. So our audience is, I don't know, Chris, what do you think the count was? I know we had about 81 at one point.
I've seen 84 people at some point. At any one point in time, we're probably approaching 100 unique people that attended.
Okay. And just so I don't want folks to sort of hang up and leave the meeting right away. Jim Thompson has something special for us. So I'm just going to turn it over to him for a second to explain our post-meeting get together virtually. So Jim, can you unmute yourself there?
Sure. Can you hear me all right?
Yep.
So for those who are interested in doing a little bit of live observing online, I have my telescope open and set up, and I am ready to go. So if you're interested, just stay on the line on the Zoom meeting and we'll carry on from there.
Okay. So thank you to everybody who participated in the meeting this evening. And again, while Greasel Valleys may be open, we're not going there tonight. And next slide. Okay, so we welcome all public are invited to our meetings, but if you wish to become a member of the Royal Astronomical Society, we have regular memberships at $88. A family membership is $82.50, and then $15 an adult, $8.10 a youth. Youth memberships are for youth under the age of 21 years old or under 25 if they're still a student, and that's at $53. So you say, well, what do I get for that? Let's go to the next slide. Oh, sorry. If you're having financial challenges in renewing your membership, please email our local president, and we do have funds to assist you. Next slide. So benefits of being a member of the Royal Astronomical Society. We have the Ted Bean Loan Library. So we have telescopes that we can loan out to you. When the museum reopens, we have our library. We also have our private observatory out near Almont, the Fred Lawson Observatory, which you can use as a member. Next slide. Also as a member, you get the every second month, you get Sky News, which is published by the Royal Astronomical Society of Canada, their journal. You get the Observer's Handbook at the end of the previous year for the next year. And we have our local newsletter, Astronauts. Okay, so as I said, our next meeting is September the 11th. It's the second Friday. And we have 2 special out-of-town guest speakers for that meeting. And so what we're going to do at this point, I don't think there's any more slides, right, Chris?
That's the last slide. So once you're finished, Dave, it'll take me a second just to stop some of the recordings and switch over control to Jim. Okay, so just if you want to participate with Jim and his observing, just give Chris a second here. He's going to have to stop the slideshow, make Jim a co-host, and then the meetings, he's in charge of the meeting. So just give us a second here. Thank you for coming out tonight.